Now, what do we do if we have both phase shift and a change in amplitude? Once again, we're going to go for the original or parent function. In this case, we have sine. So the parent function is simply y equals sine of x. And you can start by sketching that if you like to do it visually, or if you like to go coordinate by coordinate. So in this case, let's go for the amplitude. You have 5/2, that is 2.5. So that will allow you to see what's going on with the amplitude. The 2.5 is here, and minus 2.5 are here. Or if you go 1/2, 2/2, 3/2, 4/2, 5/2, same thing. 5/2 is there, and minus 5/2 is right there. So that means that the graph is gonna be, or is gonna go as high as 5/2, that's the maxima, and the minima is gonna be down here. Now, the original graph has a period of 2π. And we don't have anything multiplying the x, so the period is gonna stay as 2π. So the original graph is gonna have a period stopping at 2π. So basically, if you wanna sketch the original function, you're going to have something like this. You're gonna enclose the first cycle of your graph. And it should look something like this. Because it is sine, it'll start here and end here, just like you see here. Starts and ends as an x-intercept. Then we have another x-intercept in between. Then in between x-intercept, we have the maxima and the minimum. If you happen to end up with a negative a value, the amplitude would still be the same, but it would be reflected. So now the original graph is gonna go something like this. So quite straightforward there. And then it's about the phase shift. How do we find the phase shift? So basically we grab the same input, the argument of the sine, and we set it equal to the first value, the 0. And we solve for x. We're gonna get x is equal to π/2. What does that mean? It means that the graph is gonna jump π/2 units to the right. So if this is pi right here, so half of that is π/2. So it means that we need to move 2 rectangles to the right. So this point is gonna move 2 rectangles to the right, 2 rectangles to the right, same here, 2 to the right, and 2 to the right. And we're gonna sketch the final graph. This is the starting point, maxima, another intercept, the minima, and another intercept. So the final graph is gonna go like this. Now, some of you like to do it directly on the coordinates. So if you wanna find the actual coordinate first, you're gonna go like this. The A multiplies the entire sign. So you're gonna multiply entirely the y value, the output. So you're gonna multiply this by 5/2, 5/2, by 5/2, same, by 5/2, and by 5/2. So the output is gonna be 0, 5/2, 0, minus 5/2, and 0. Exactly what we got. Now, if you wanna find what happened to x, I'm gonna use green, you're gonna set the argument of the sign entirely equal to all of those values. So you're gonna do x, and that's the one that we already did, x minus 5/2 equals 0, x minus pi halves equals pi halves, x minus pi halves equals pi, x minus pi halves equals 3 pi over 2, and x minus pi halves equals 2 pi. So it's going to be very similar to the previous problem, where you're going to end up with x being equal to pi halves, as we already knew. Then we're going to have x is equal to pi. Then we're going to have x is equal to 3 pi over 2. X is equal to 2 pi. And x is equal to 5 pi over 2. So the final graph is the pink one. So we don't really need all of that anymore. Let's get that out of the way. Oops. And if you want to write down the coordinates, feel free to do it over here. So you're going to go as pi halves, comma 0, then pi, comma 5 halves. Then we're going to have 3 pi over 2, comma 0. Then 2 pi, comma minus 5 halves. And finally, 5 pi over 2, comma 0. And there you go.